Welcome to Get Your FRQ On. This question is from 2007. It's question 2, and it is calculator active. In the question stem, we have water in a tank, and we have two functions. F of t tells us the rate at which water is entering the tank. G of t tells us the rate at which water is leaving the tank. We have the graph of these two functions overlaid with one another so we can see their graphs one on top of the other. We're also given in the question stem the two locations for t where the two graphs intersect, and we know that at t equals 0 there are already 5,000 gallons in this tank. So in question A, we are asked to the nearest gallon how much water is entering the tank for t equals 0 to 7 hours. All right, so the amount of water entering the tank over that 7 hour period, t equals 0 to t equals 7, is just going to come from the integral from 0 to 7 of f of t dt. Right, so that would be the integral from 0 to 7 of 100 t squared sine of square root t dt. And because this is a calculator active question, we're going to use our calculator to calculate this integral. And to the nearest gallon, which it does ask for, that would be 8,264 gallons of water entering the tank over that 7 hour period from t equals 0 to t equals 7. In part B, for the interval from t equals 0 to 7 hours, what are the intervals where water is decreasing, and then provide a reason? Well, we have two functions. F of t tells us how quickly water is entering the tank. G of t tells us how quickly water is leaving the tank. The water in the tank should be decreasing if it's leaving at a rate that is higher than the rate at which it is increasing. So what we want to make sure happens is f of t minus g of t must be negative, which would imply that f of t is less than g of t. Now, because we have the graphs here, we can see where they intersect, but we're also told in the question stem where they intersect. So g of t is a piecewise function. It's just two linear functions, and then f of t has got some curvature to it. But we can use the information in the question stem. We're given, and based on the graphs provided, that f of t is less than g of t for t equals 0 to 1.617, and again from t equals 3 to 5.076. So if that's what we need in order for the water to be decreasing, those would be our intervals where water is decreasing. The amount of water in the tank is decreasing between t equals 0 and 1.617 hours, and then again for t between 3 and 5.076 hours. In question C, for the interval from t equals 0 to 7 hours, when is the water at a maximum and how much water is there? All right, so the amount of water in the tank will be at a maximum either at 0 or 7, because those are the endpoints, or somewhere in between 0 and 7 where f of t minus g of t is equal to 0. All right, or possibly f of t minus g of t is undefined and changes sign from positive to negative. So we have a couple of different things going on here. It is a closed interval, so we would need to check the endpoints. And remember that there's a couple of criteria a function could meet in order to have an extrema. One of them is that its derivative is 0, but the other one is that its derivative is undefined somehow, and still the derivative changes sign from positive to negative. All right, well, f of t minus g of t is undefined at t equals 3 and also changes sign from positive to negative. So t equals 3 has the criteria necessary to be a possible location of a maximum. All right. However, we don't know how much water is in the tank at t equals 3 until we find it, and we don't know how much water is in the tank at t equals 7 until we find that. So let w of t be a function that represents the amount of water in the tank in gallons at time t. Based on the question stem, we know w of 0 is 5,000. At w of 3, we would need to do 5,000 plus the integral from 0 to 3 of f of t minus g of t dt. But this is a calculator active question, so we can have our calculator do that. That turns out to be 5,126.591 gallons. And then w of 7 we can find in a similar way. That would just be 5,126.591 gallons plus the integral from 3 to 7 of f of t minus g of t, which again we can use our calculator to do. That's 4,513.807 gallons. So of those three possibilities, the water is maximum at t equals 3 hours, and there will be 5,126.591 gallons. To the nearest gallon, 5,127 gallons of water at t equals 3 hours.